Welcome to the deep dive. We're here to really get into the details, pull things apart, and hopefully give you some solid insights.
That's the plan.
Today, we're looking at something called MTOR. There's definitely some buzz around it,
Mm-hmm.
but we're going straight to the source code. We've got the front-end JavaScript, script.js.txt, and the Python backend logic, webguide.py.txt.
Yep, grounding it in the actual code. That's the best way.
Our mission, really, is to see what this code tells us about MTOR's architecture. What makes it pick?
Exactly. We want to understand its core claims based on what's written. Things like being 100% event-driven, this idea of a kernelless operating realm,
Right.
being stateless, asynchronous, and maybe most intriguingly, this intent-driven aspect.
And also the in-browser RTOS concept and how it shifts from programs to workers. Lots to unpack.
Definitely. It points towards potentially a new way of thinking about computing, maybe even unifying things, and democratizing AI down the line.
Okay, let's start with that event-driven part. Looking at the JavaScript, script.js.txt, I mean, wow, the number of event listeners just jumps out.
It really does.
You've got DOM content loaded, WebSocket on open, on message, tons of button clicks. What's the big takeaway there?
Well, it's fundamental, isn't it? The sheer number tells you this isn't a system that just runs top to bottom. It waits. It reacts.
Reacts to what the user does or what comes in from the network.
Precisely. User clicks, WebSocket messages, those are the triggers. It's designed around responding to events, not following a rigid script. It makes the whole experience feel, well, more alive, more dynamic.
Okay, makes sense. Now, this kernelless operating realm idea
Yeah.
sounds deep, but like you said, we don't see kernel code in the JS or the Python. So what does kernels actually mean here?
Yeah, it's a bit of a nuanced term in this context. It's not saying there's no kernel involved anyway in the stack, obviously.
Right.
Your browser runs on an OS, the server runs on an OS. But MTOR itself, in these layers we're looking at the front-end logic, the application backend isn't managing hardware directly, it operates at a higher level.
So it's using the browser's environment and the server's environment.
Exactly. It leverages the abstractions provided by the browser and the application server, which in turn rely on the underlying OS kernel. So MTOR's direct operational world in these files is above the kernel level.
Got it. It's working within those existing managed environments. Okay, what about stateless? This one always trips me up a bit. How can it be stateless if it handles things like user access tokens in the JavaScript or user IDs in the Python? Doesn't that imply state?
That's a really common point of confusion. Stateless in this architectural sense doesn't mean zero memory ever. It means each request, each interaction is treated independently by the core processing logic.
Meaning the server doesn't have to remember the last thing I specifically did to process the next thing.
Essentially, yes. The state needed to process your request, like who you are is either sent with the request itself or retrieved from somewhere external just for that transaction.
Like local storage in the browser, which we see in the script.
Exactly. Or a database on the back end, which is implied for handling those user GODs. The core application logic, the part handling the event or request, doesn't hold on to your session state between requests.
Ah, I see. And that helps with scaling, right? Because any server instance can handle any request.
Absolutely. That's a primary driver for stateless design. Massive scalability. You don't have sticky sessions tying a user to one specific server that holds their state.
Makes sense. Okay, next point. Asynchronous operations. We see async and await pretty much everywhere in both files. Handle Gmail auth success, read emails in JS, lots of functions in the Python backend too. Why is this so central?
It's crucial for performance and responsiveness, especially in a system that interacts with external services or handles multiple things at once.
Like talking to Gmail APIs or managing those AI workers.
Precisely. If it were synchronous, the entire process would just stop. It would wait for Google to respond or for that AI task to finish before doing anything else. The user interface would freeze, the backend couldn't handle other requests. A sync await lets the system fire off a request like, go read those emails, and then immediately become available to do other things, respond to a button click, handle another incoming message. When the email data eventually comes back, the system picks up where it left off for that task.
So it keeps everything running smoothly, avoids bottlenecks.
Exactly. Non-blocking operations, fundamental for modern web applications and scalable backends.
All right, now for the really intriguing part, this intent-driven idea. The script mentions wake word detection, handle top-level command, handling things like Gmail, Vision, Imagine. How is this code showing an intent-driven system?
Well, look at the nature of those commands. Gmail, Imagine, they aren't precise function calls, are they? They're expressing a user's goal, their intent.
Right. You're not saying execute function generate image with these parameters. You're saying imagine.
Exactly. The user states what they want in relatively natural language, and the system is responsible for figuring out the how. It translates that high-level intent into the necessary sequence of actions or calls to specific workers or services.
So the system interprets the goal.
Yes. It's a shift from imperative commands, do this and this and this, to declarative intent, I want this outcome. This makes interaction potentially much more intuitive.
That is a different way of thinking. Okay, related to this responsiveness, the outline mentioned an in-browser RTOS real-time operating system. Is script.js, with its event handling, audio, maybe camera stuff, acting like an RTOS in the browser?
It's maybe better to think of it as exhibiting RTOS-like characteristics within the browser sandbox. A true RTOS has very strict guarantees about timing, often down to microseconds, which a browser environment typically can't provide.
Okay, so not a hard RTOS.
Not in the traditional embedded systems sense, but look at what it's doing. Managing multiple asynchronous events, handling inputs from the user, network, potentially sensors like the microphone, prioritizing tasks implicitly through event loops and async handling, all to provide a timely, interactive experience.
So it's juggling resources and responding quickly, which is what RTOSs do.
Kind of, yes. It embodies those principles of responsiveness, concurrency, and resource management, but adapted to the specific constraints and capabilities of a web browser environment.
Got it. Okay, let's shift to the back end with webgate.py.txt. There's this concept of the demise of programs and the rise of workers. We see this AI worker class handling chat, vision, imagine queries. They have health checks. They can be blacklisted. What's this worker model about?
It suggests a move away from large, monolithic applications doing everything towards a collection of smaller, specialized, independent units, these workers.
Each designed for a specific kind of task, like one for chat, one for image generation.
Exactly. The back-end system, WebGuide.py in this case, acts more like an orchestrator or a manager. It receives an intent, figures out which worker is best suited for it, routes the request there, maybe checks if the worker is healthy first.
And you can update or add workers independently.
That's a major potential benefit. Modularity. Scalability, you can scale up the number of Imagine workers if needed without touching the chat workers. Resilience. If one worker type fails, it doesn't necessarily bring down the whole system. It's a more microservices-like philosophy, perhaps, applied here.
A system of systems, almost. Okay.
Yeah.
How does this connect to the idea of global scale code and unifying computing? The link seems to be the WebSockets connecting the browser front end to this worker managing back end.
Right. The architecture itself enables distribution. The front end is just a browser tab anywhere in the world. The back end could be anywhere. And crucially, the workers managed by that back end could be distributed even further on different servers, in different data centers, potentially anywhere.
Because the back end just needs to know how to talk to them.
Yes. And the unification part comes back to that intent layer. If users and devices interact via intent, I want to do X, the underlying platform differences, Windows, Mac, Linux, mobile, cloud servers running the workers, become less important.
Because the system abstracts away that complexity.
Precisely. MTOR, through this intent layer and worker orchestration, could provide a common way to access diverse computational resources, regardless of where they are or what platform they run on. That's the potential unifying aspect.
Okay, that leads directly into the final point. Democratization of AI. The Python code shows it can use local AI workers and cloud services like Hugging Face or Claude via API keys. How does this, combined with the intent interface, make AI more accessible?
Well, first, the intent-driven interface itself is huge, right? You don't need to be an AI expert or a programmer to say, summarize this document or translate this into French.
It lowers the barrier to entry.
Massively. Second, by integrating access to potentially many different AI models and services, some may be running locally for privacy or speed, others using powerful cloud platforms, it brings a broad range of AI capabilities under one roof, accessible through that simple interface.
You get access to sophisticated AI without needing to manage all the different APIs and models yourself.
That seems to be the goal, to make interacting with diverse AI as easy as expressing your need. That's the core of the democratization idea here, putting these powerful tools into more hands, through abstraction and ease of use.
So wrapping this up, looking at the code, the picture that emerges is, well, it's pretty consistent with those core ideas. It is heavily event-driven. It does operate in a sort of kernel-less realm at the application level. Statelessness enables scaling. Asynchronous operations are key for performance. And this intent-driven layer interacting with specialized workers that feels like the most potentially transformative piece.
I'd agree. The code provides tangible evidence for these architectural choices. We see the event listeners, the async await, the worker management logic, the handling of natural language commands.
And together, they paint a picture of a system aiming for global reach, a more unified way to access computation, and making advanced AI much more approachable.
Exactly. The choices reflected in this code aren't trivial. They point towards a deliberate design philosophy focused on intent, distribution, and accessibility. A potential shift in computing, as you said.
It's definitely given us a lot to think about, based just on the code itself. Which leads to the final question for you listening. If this intent-driven distributed worker model takes hold, what kinds of entirely new applications or interactions might become possible? What does that future look like?
A big question to ponder.
Indeed. Thanks for joining us on this deep dive.